In this video, we're going to talk about elevations. Now, this is the first sheet. This is one of the sheets you're going to draw for the work you're doing in this class. Sorry, brain just for some reason just stopped, probably because it's so cold today. And it shows you in this sheet, it shows you the elevations of the house as well as a perspective. Now, what you're going to be doing in Revit is you're going to be building this as a model. And so then once you have the model from there, you tell the computer front elevation, rear elevation, right side elevation, left side elevation, and put those on a sheet to give that information to a contractor. And basically, these are the kinds of information, and this is missing some information, but this is all you're drawing just to be able to get comfortable with setting these up. So you're going to build the model, and then you're going to, from that, create the elevations. Now, things that elevations communicate are largely materials, and this allows the contractor to do a takeoff on how many materials that they need to purchase to complete the project. It also gives information like that you can't put anywhere else on a drawing, such as you can see over here, the pitch of this roof is 1214. Actually, yeah, well, this roof, the gabled end here. And then there are notes as well about trim, molding. Usually there is something called a window schedule with the elevations that will take all the doors and windows and draw an image of them and give detailed information so that those can be properly ordered. There are no, you can see on this, there are no indicators at all of dimensions or marks that tell you the elevation height from the finished grade. There's no indication of the finished grade. That should be on there. It's information that the contractor needs to know. But the purpose of this class is to get you guys comfortable and familiar with the process. As we move forward, we can start looking at and using documents that have more information on them. And so for this class, you're just duplicating this information. Now, one of the things you want to think about is what information would you need to be able to build this? That can't go on a floor plan or a building section, or, we're not getting into building sections yet, but there is information that only can be conveyed on an elevation, and all that information is height. So first things are like, where's the finished floor? And that is a symbol that we use as sort of like ground zero. So that the contractor knows, based on what's around the house, how far off the ground is the finished floor. And then from the finished floor, how high up is the eave? How tall are these railings? This is information that's not given. How far up do they go with the framing to know how to frame out this window? Where's the header, right? So any additional information you can give them, the contractor, to help them build without duplicating information. You want to put something once on a set of documents, and that way it's the only place you ever have to change it. Because if you put notes on two different sheets that refer to the same thing, and you change one of them but not the other one, now you have conflicting information. And so we always talk about how don't do the bare minimum necessary. Well, I mean, that's mostly true, except when it comes to information on construction documents. You want to only put necessary information, and you only want to put it on once. Because, like I just explained, you can very easily change something in one place and miss it in the other. So that's pretty much it for the elevations. You guys are more or less going to build the model in Revit using walls and roofs on top of the foundation, and then use that model to cut your elevations. And then you can compare yours to the model to determine what needs to be adjusted. Now, this is what I'm gonna. This is another lesson. This is actually a accidental lesson, but this is a good lesson. So we know certain dimensions. We have certain dimensions based on the floor plan. You can take that dimension, for instance, let's say the front elevation. We know how wide the front of the house is based on the floor plan. That's given to us. You can now take that, print this sheet, and using algebra, you can solve for all the missing dimensions. And I can tell you that I have in my career been given floor plans that were not to scale. And I needed to then draw them in the computer to be able to renovate or add on or whatever I needed to do. And in commercial architecture, a door is always 3 feet. So we could use algebra to measure what was there and then set that as a fraction, right? The known dimension is to 3 feet as, and then go measure something else. That known dimension is to x, and then solve for x by cross multiplying. And that will give you all the dimensions you need. So you just essentially go find what's this dimension across the front elevation, print this out, and then measure with a scale what it scales at on your scale, and then stack it as a fraction. The measured dimension to the known dimension equals, and then I'm going to come over here and say I want to know what this height is. I'll measure that, and that'll go on the top just the same as my other one was on the top, equals this known other dimension over x. What is it really? Solve for x. Cross multiply, and then solve for x. And that's how you can get all your dimensions on that page. Okay? Let me know if you have any questions.